I'm going to take you from the real estate, I'm going to take you to the real estate which is moving, so mobile real estate. I'm going to talk about the cruise industry with you and the challenges what we are having, actually mainly in our scope 3. We talked a lot about it already today and yesterday. I think I can give a little bit of a different direction to that. So first of all, what are we talking about? A cruise ship is consisting out of, well, more or less, depending on the size of the vessel, of 15 million different pieces. And all those pieces are coming together to one big cruise ship. Where are we doing that? Just a little bit of company background. Our main company is Meyer Werft in Papenburg, the northwestern part of Germany, near the Dutch border. It is a family-owned company. The end of the 90s, we bought Neptune Yard, and since 2016, also Meyer Turku in Finland is part of the Meyer group. It's a family-owned business, also divided into 2 different foundations. So in Finland we have a foundation, and in Germany we have a foundation that is also based on if one of the family dies, that the company is still able to be run in family ownership. So a final product, this is one of our most sustainable products that we have built. It is the Silver Nova, which we have delivered about 2 months ago. And that is giving you an impression of what we're actually doing just in a nice picture. But what is this real estate? A moving real estate then all about? Just to give you a little bit of an impression. So we have everything on board of this ship. We are completely self-containing. So we have our own power supply. We need this power supply, of course, for everything what we do on board of the ship and for also moving the ship. And on board of this ship, it is kind of like a small city. So we need water supply, we need waste disposal, we need water treatment, but also everything that the people do for living. They need to eat, they want to have entertainment because they're on holiday. So everything that you normally do on a holiday, that is included in a ship, and it is even also moving. And just to give you a little bit of an overview what the size we are talking about, so it is about 30 million passengers that are traveling on a cruise ship every year. And if you would take out all those 30 million passengers, I think real estate would be very happy about that, but then you would need some 2,700 hotels around the world extra. So we are quite happy that we still also have a couple of people that want to sail around on a ship. Based on that is what I want to give a little bit background on as well. As we are doing everything what we need on board of the ship itself, we have very short distances in the transport of everything what we need, whether it's water, whether it's electricity, whether it's transport on board of a ship. So this sailing city is quite efficient in the use of its energy and the use of everything what you need for life. But that is actually not what you wanted to hear from me. So where are we coming from and where do we want to go to? So I'm a little bit, don't be afraid, it's going not to go into a lot of detail of technology, but I want to show a little bit of where we are coming from and where are we heading to, just to come to the scope 3 actually. So in 2008, not much has been done on really emissions on board of a vessel. We were still sailing around with heavy fuel oil. If you read in the press, that is the worst fuel that you can get. It's kind of a waste product out of a refinery, and nobody wants to have it, so just burn it in a ship and it is moving around. So that was kind of how we did it more than 50 years. But then at that time, still not many people were talking about sustainability. We were talking about emissions actually in ports. And it was not coming from the cargo industry, it was coming actually from the cruise industry, because the ships from the cruise industry are mainly in port in the middle of a city center. So they are visible. And if you're having a real estate somewhere in the port of Hamburg, you're sitting there in a nice city with your 5 million apartments, and you're sitting at your breakfast on Sunday morning and a cruise vessel is coming in and your white egg all of a sudden is black, you don't want to have that on your own balcony. And that is actually based on soot, so particle matters. So we need to have a solution for that. And we also had regulations for sulfur emissions. That's also not really what you want to have within your lungs, so one want to get rid of that. And in the early 2000s, we already start to think of how can we get rid of that, and the solution was LNG. And it was the early 2000s that we started working on that. We did a little bit also on cleaning the exhaust gases of the heavy fuel, but we thought, well, let's move for LNG, because LNG is solving more or less 100% of the particle matters and 100% of the sulfur, and it's also doing a big step in the NOx. So, well, it looked like kind of a good solution. And then in 2008, we delivered our first vessel on LNG. But everybody was talking about CO2. Nobody was talking anymore about any particle matters or any sulfur, because, well, we're talking about sustainability, and sustainability, yes, it is ESG, but everybody is thinking as sustainability is CO2. So we did a lot of efforts in getting better in any kind of emissions, but we only reached on 20% in CO2. So everybody was talking to us, you need to do better in your emissions, but you're doing crap. You're taking a fossil fuel and exchanging a fossil fuel with another one. Yes, we did, but we delivered a sustainable solution for the problem that we saw already in the early 2000s, and we needed to until 2018 to solve that problem. And we delivered this vessel in 2018, which means that we got the contract in 2014, but the rules and regulations to use LNG on board of a vessel were coming in 2018. So in 2014, we actually took in a contract of a vessel that we didn't know whether we were able to build it according to regulations. So that is giving you a little bit of an overview how slow we are moving, because the regulations are international, and international means that you have to cover the ideas of almost 200 different countries and NGOs, and they all have to agree on the rules and the regulations. So it's not only about Germany, which is difficult enough already. It's not about Germany within the EU, which is even more complicated. We're talking about regulations valid for the whole world. But still we think, well, in 2030, our customers, or a lot of our customers, are saying we need to have climate neutrality in our operation. And we are thinking that we are able to provide that due to different kinds of fuels, due to batteries, and due to fuel cells. Everybody who might know fuel cells from land-based would say, well, it's going to be easy. Fuel cells, they are there already since the 80s of the last century. Yes, for land-based they are, but we are moving with our ships and we are on a very salty environment. So those fuel cells that are available for land-based, they are not working on our ships. So the Silver Nova that I just shown is prepared for using all those kind of fuel cells technology. But it is expected that you can buy them off the shelf in 2028. And at the moment we are talking about fuel cells of 500 kW of output. And for a full cruise ship in the size, double the size of what I've shown you before, the Silver Nova, for a full cruise ship we are needing 70 megawatts of energy to be able to provide energy to the floating city and move this city around. And as we are at 500 kW and we need to go to 70,000 kW, you can understand that this is going to be a challenge. But why are we still thinking that we are the ones that are needing to do this? As said, the person sitting on the balcony somewhere in the middle of Hamburg, they see a cruise ship. Well, if you look a little bit better, then you might be able to see a cargo ship as well, but the cruise ships, they are visible. We are only a very small part of the seagoing ships, so it's about 0.5% to 1% of all the seagoing ships is coming from the cruise industry. But we see, because of the visibility, because of the pressure from external, because we want to be innovative and a front runner, we see that the cruise industry is actually the innovation driver of the whole maritime industry. We actually were able to provide a ship, although there were no regulations for that ship. There was not another company, that was not another industry in the maritime industry. Now jumping to sustainability, Why now sustainability? All what we did in the past, that was about energy efficiency, it was about cost. Yes, it has a direct link, of course, to sustainability, because if I'm saving fuel, I'm saving cost, and that was the main driver. But if I'm saving fuel, it is also more sustainable. Everything that I would not need is of course more sustainable. So ESG, you all know that. I'm going to jump over that, but this one, you all know that as well. But this is actually the most important one, the product use. Because our products are sailing around 365 days a year in 25, 30, 40 years, and they're sailing at the moment on fossil fuels. So this part of the downstream emissions is going to be our bigger part, but I'll come to that later, because first of all, we all need to look at our scope 1 and 2. Everybody is giving the pressure through the regulations on scope 1 and 2. Scope 3, yeah, if you can do something, have fun with it. If not, just explain why, and everybody's happy that you're not doing that. So scope 1 and 2 is the first part of it. And then the left part of it is extremely important for us. So the scope 1 is actually somewhere 70-75%, depending on what year we are having and what ships we are delivering. 70-75% is the scope 1. And as we are not having complete green energy at the moment, the rest is, of course, is scope 3. But why is the scope 1 so important for us? Every single ship that we are delivering, we need to test that, because quite often it is a prototype. We are not building long series of ships, so it is quite often a prototype. And our customers are only taking the ship from us if it is fully tested, which means we do commissioning on the shipyard, and we're going on sea trials with that ship. And for that, we need, of course, the fuel to run the ship. And this fuel is actually about 50% of our complete scope 1 and 2 emissions. And as long as we are running on fossil fuels, this is still within our analysis that we have to list that in our scope 1 emissions. We might go in the future to synthetic fuels, biofuels, or whatever, but our customers are sailing with their ships around the world. So as long as they cannot get a synthetic or a biofuel at the other side of the world, they want to see that the ship is still able to run on fossil fuels as well. So in the future, this might even go up, although we are getting better in having fuels that are synthetic or bio. But if we need to test them on both types of fuels, at least in the beginning, the balance sheet is not looking very good. Then going to the scope 3, as said, category 11, use of sold goods. It's a nightmare for us on the balance sheet. And everybody's also talking about the upstream emissions, the purchased goods and services. Those are the main ones for us. The other ones, well, I'm not going to go through them. They're kind of neglectable. So what is it then in the upstream part? So not the operation of the ships, it's just the purchased goods. It's not all the other stuff that is in the upstream in there. It's just the purchased goods on top of scope 1 and 2. Well, if you look at some kind of smart professors that did a little bit of research on that, they're coming up with about 80% of scope 3. Well, it matches with our estimates. It is based on the weight calculation according to the greenhouse gas. So how much weight do we have in the ship? What is the material of that weight? And then you put a factor on that, and then we get about 80%. And now we are putting actually the downstream scope 3 emissions on that. It's not completely according to the greenhouse gas protocol, how you calculate that, because a ship is built for at least 25 years. So according to the greenhouse protocol, we need to estimate the emissions for 25 years of operations. Most of the cruise vessels are running more than 25 years, 30 years, 40 years, whatever it is, sometimes even 80 years. And the cruise ships, they are actually refitted. 5 years, a small refit, so taking carpets out, and 15 years, all technologies that are taking out, we're getting more energy efficient and all that kind of stuff. And in the past, in 25 years, we had an increase of efficiency of about 80%. If we are calculating according to the greenhouse gas protocol, and we would say, well, in the last 25 years, we had an efficiency increase of 80%, can I then do a calculation of the greenhouse gas protocol? 25 years, 80%, so the first years we might have 40%, and then the last years 40%, adding it up, then I have the 80%. So do I have to calculate 25 years energy efficiency, 80% reduction is in average 40%? or how am I going to calculate the downstream emissions? So this 95% is actually not an estimate of the ships delivered in that year for running 25 years. It is actually all the cruise ships that the Meyer shipyard in Germany has delivered in the past that are still running today. And then we are talking at the moment about approximately 50 ships. And those 50 ships, I took the emissions of this year, or of last year, because this year is not fully over yet. And then we're coming about 95%, which is much more than as I would have to use only the 2 deliveries per year and then calculate that for 25 years. So we are still having ships in operation that we have built that are almost 40 years old already, and that is in the 95%. But if you're looking at that with the promise in 2030, you would be able to have climate neutral products. And we would calculate it according to the greenhouse gas protocol. So not looking at the fleet anymore that is still in operation, what we have built in the past, but we are building in 2030 2 or 3 cruise vessels that you could run in a climate neutral way, and we would test it in a climate neutral way. So we could take out all the fuels for commissioning and for the sea trials. And then all of a sudden the picture looked like this. So the full scope 3 downstream emissions, the operation of the operator, at least for us, not for the operator, because he has his whole fleet again in it, what I could take out of the calculation. Then all of a sudden this 95% drops down to 0. Well, it's a nice vision. Hopefully we could be able to do so. But then all of a sudden also a little bit of a change in the upstream scope 3 emissions compared to actually the scope 1 and 2. Because also our scope 1, just explained it in the beginning, 50% of our scope 1 is actually the fossil fuels that we need for commissioning and for the sea trials. So I can take those ones out as well. And all of a sudden our scope 1 is smaller than our scope 2 if we do not buy any kind of green electricity or provide our own electricity. And then all of a sudden we have almost 90% of our upstream scope 3 emissions, so the materials that we are buying from our suppliers. So this one is going to get even more important. And on top of that, I'm having the feeling we are able to solve our CO2 emissions in the future. If we would not be convinced about this, I don't think we would be here, because then we wouldn't believe in our own jobs. So I'm convinced that we are able to do so. But then we are running in an even bigger problem. If we want to have a world that we know today, we need actually raw materials. And those raw materials are providing us with, in the future, potentially the 90% of emissions in our scope 3. So what can we do about that? Well, at the moment, it is not a strategy. It is not a roadmap. I'm going to show a vision, what we are having. And this vision is actually covering everything. Well, if you don't have a vision that covers everything, you don't have the right vision. So it needs to cover everything. And a lot of this we are already doing today. So product development, how can we get to a climate neutral ship without CO2 emissions? Well, we are hoping to be able to do that already in 2030. But we heard it today and yesterday as well, that every energy that you're not using is better energy. So we still need to look at an improved energy efficiency. Low-hanging fruits are gone already. So at the moment, if we want to do, for example, hull form optimization, pushing or pulling a vessel, depending on what kind of type of propulsion you're using, an object to the water, through the water, of course, you have a resistance. And we did a lot of research in the past, and at the moment, if we are changing anything at the hull form, we can maybe optimize still somewhere in the range of 1 to 3%. Well, if you then think of the calculation methods and the model testing of a hull form is giving you an accuracy of 1 to 3%. Then you're thinking, why am I doing that? Because maybe the calculations are saying you're doing good, but in reality you're doing bad. And it also depends on where you're sailing. In the past, we had a ship, 2 exactly the same sister vessels. One was running in the northern part of Europe, an average water temperature of 15 degrees, and one was running in the Caribbean, an average water temperature of 25 to 30 degrees. And then all of a sudden, just delivered both vessels, the customer was calling us and said, You made a mistake with the ship that is running in the Caribbean. There is a guarantee issue. Yeah, what do you have? Well, we're having 20% more energy that we are using for that ship compared to the ship what is running in Europe. And they are sister vessels, so they are exactly the same, so they need to have the same energy consumption. It took us quite a while to figure out that only the difference was the water temperature. And with the water temperature, you're changing the viscosity of the water, and with the changed viscosity, you're actually changing the resistance of pushing an object to the water, through the water. And this huge change of viscosity, we all of a sudden started to understand, what are we doing here? We are offering a product which is, according to the contract, capable of sailing wherever it is, should be in the world. So if there is something happening around the world, for example, Russia, nobody is sailing to St. Petersburg anymore. The ships are taken away from the Baltic Sea and they're moving somewhere around. Well, it's a positive idea that you can move your ships around and you do not lose your business. But that means that your surroundings are completely different. And all of a sudden, your viscosity, as an example, changes. And your energy efficiency, that you said, well, I did a good job, I saved 5% of energy by just moving the same ship to another area of the world, you're losing 20% without doing anything on the ship itself. So improved energy efficiency, you need to look at your full operation. We need to have still the flexibility of a ship to be able to move it around. But is it the right thing to actually write in a contract, we can only test it on 15 degrees of water temperature and then everybody is happy? Or do we have another idea of how we are using such a product? So product use is changing mindset. What are we really wanting to do with that ship? And at the same time, Brussels regulations. Yeah, unfortunately, I'm going to touch that a little bit as well. No local emissions. That is what we are looking at. Think of the guy sitting at his balcony, or the family sitting at the balcony in the port of Hamburg again, or the fjords in Norway. Norway is saying that from 2026 onward, in the fjords of Norway, no local emissions are allowed anymore. Well, local emissions means that you don't have any emissions coming from your funnel while sailing in a port or through a fjord. But at the same time, no emissions means that we only have, if we're looking at say CO2, for example, we have hydrogen, we have battery systems, and in the worst case, we have ammonia, because there is no C in ammonia either. But all those three different types of energy carrier, I'll talk like carrier storage of them. So hydrogen, for a seagoing ship, well, there's not much energy in hydrogen. So if we want to sail around the world with a ship, no matter whether it's a cargo ship or it's a cruise ship, with hydrogen, you won't get far with the sizes of the ships that we are having today. And we are wanting to build a cruise ship with passengers on board. We don't want to build a hydrogen carrier. The same goes for batteries. Yes, we are putting batteries already now on board of a cruise ship, but we are not putting the batteries on board because we are so happy with the batteries at the moment. Batteries, they don't have much energy in there compared to the weight. So we would build a battery carrier. Why are we having batteries on board of a ship already right now? A fuel cell is running on a constant output. And you can't just have a big change in output and power output. So if you don't need the power, you can't just say, as you do it with an engine, put foot from the gas and you have less power. Not possible with a fuel cell. So the fuel cell, you're running on constant amount of power and you use the batteries to take out the fluctuations. But only batteries, well, not good enough, because then we have a battery carrier. Ammonia, I don't know who of you knows ammonia a little bit. Not a great idea for a cruise ship with passengers on board, because our highest priority is still the safety of the persons on board. If you're sailing across the Atlantic and something happens with safety, there's nobody there that helps you. So safety is the first priority, no hydrogen. So what are we able to do? We need to look at different types of fuels, but those different types of fuels will have a C in there. Whether it's e-methane, whether it's biomethane, whether it is e-methanol, whatever it is going to be, it has a C atom in there. So we are not looking for zero emissions, we're looking for climate neutrality. This difference, quite often regulators in Brussels do not understand, but there is a difference, a clear difference between zero emissions and climate neutrality. We are looking for climate neutrality, but locally we need to look for zero emissions as well. So we need a lot of different types of energy generators on board of a cruise ship to actually follow up on all the different legislations. But how to get then there from the problem, what we are going to foresee in the future, if we are solved the climate neutrality, we are getting at the life cycle management. We learned a lot already these 2 days about circular economy. And circular economy, just to give you an example, did it in some table discussions already as well. If I have a carpet, like it is here, we're using 1,000 square meters of carpet on board of a cruise ship, and after 5 years we rip it off again. Well, we are not doing that, but other companies are doing that because it's just through. You can't walk over it anymore, you need to have another one on it. There are cradle-to-cradle carpets on the market available. They are produced in Europe. We produce the ships in Europe. Well, short transportation ways, all great. Let's buy a cradle-to-cradle certified carpet. Is that in the end a good idea? For us as a new building yard, you would say, yes, you did a good job, you're doing cradle to cradle. But then our customer starts to sail with the ship, and after 5 years it goes into a dock for a refit or somewhere in the Caribbean or in Singapore or whatever, wherever it is. They rip out the cradle-to-cradle carpet. The producer in Europe wants to have it back. He wants to rebuild the carpet out of that, and he is sending it back again to Singapore. Is then this back and forth of a cradle-to-cradle carpet, is that better because it's cradle-to-cradle certified than having a locally produced carpet which may not be cradle-to-cradle? I don't know. We are lacking the data to understand the full life cycle of the operation, the production, and in the end, the end of life of the product. And that is what I want to end with, actually. And I'm coming back with that to the real estate. Because real estate, it is actually coming from the building industry, the land-based building industry. It is also mentioned down below, urban mining. A lot of cities are actually full. It's difficult to find anything, and you need to rebuild, or you need to use the materials what you're having. So a lot of cities and companies in the real estate market are now looking at what can I do with the buildings that are actually already there, even if I want to demolish them completely. What is the material that I can take out and use again? And that we can do, of course, in a cruise ship as well, as a vision. We are definitely not there in the future. We have a floating city with a lot of materials built in there that we could reuse. So we're putting in, at the moment, almost only primary materials in building up everything what we need, 50 million pieces to build a cruise ship. And if you take it apart, you have a lot of secondary material. But this secondary material is not going that much back into the cruise ship industry at the moment. But if you want to have it back, at the moment we are building a ship in Germany. In the past it was the case, not so many cruise ships, but there were examples from that as well, that most of the ships, they're running on the beach somewhere in India or Bangladesh, and we will never see the materials in Europe again. So we need to completely change the business model. And if you look at the car industry, for example, leasing, well, then the company gets the car back, but we sell a prototype and we'll never see it again. And if we want to have some kind of urban mining, so a circular economy within the cruise industry, how do we get those materials back? Do you want to have a leasing principle? Well, our suppliers, from the 50 million pieces, we are only doing 25% ourselves. And that is mainly actually project management and steel building. So the rest is done by the suppliers. So how do we get those materials back if we do not own the materials? With the 3,500 suppliers, what we're having, so we really need to rethink the building process, the business case, to get the circular economy done, because only with the circular economy we are able to look at the life cycle and get the data from the life cycle. And that is why it is a vision, because the data is just not there. Thank you.